Greetings, everyone, and thank you for joining us. Today's webinar, Container Vulnerability Validation, is the second webinar in the HyperQube series, Know Thy Enemy Through Testing and Validation. If you missed our first one on credential dumping, you can find a link to it on the HyperQube blog at hyperqube.io. Today's session is presented by Craig Stevenson, CEO and founder of HyperQube, and Gregory Dharma LePard, sales engineer at Rezilion. Prior to founding HyperQube, Craig was a PhD candidate in mathematics and worked at Raytheon, where he was the director of cyber training, as well as the lead instructor of the cyber exploitation unit. Greg LePard is a sales engineer at Rezilion who helps organizations take control of their actual attack surface. Greg has more than 20 years of cybersecurity experience, helping global organizations with co-location, cloud, and DevSecOps security requirements. Some quick housekeeping items. All participants are automatically muted. Questions can be submitted via the chat. Those questions will be collected and reviewed during the Q&A session of this webinar. And that Q&A list will be an addendum to the deck, and that deck will be distributed to all attendees. This webinar is being recorded and will be available next week on the HyperQube blog. Containers. They offer speed and convenience, but sacrifice security, as containers pulled from a number of public repositories contain several vulnerabilities. Some of these vulnerabilities are in older layers and will never be called to memory, therefore pose no risk. Today, we'll focus on identifying and validating vulnerabilities, prioritizing them, removing unused and bloated code, and show you how to create a catalog of certified container images to meet your organization's security baselines. Today's toolkit includes the HyperQube Cyber Range to build and test live infrastructure, Trivy open source scanner to scan the environment for vulnerabilities, and Rezilion Prioritize to validate the vulnerabilities present in container images. And now I'll turn it over to Craig Stevenson to show you how he builds environments in HyperQube. Craig?
All right, thanks, Greg. So share my screen. All right, so imagine you're a security architect. Your dev team is ready to deploy a new feature that's supposed to drive revenue for the next quarter. It's your responsibility to validate the security posture and risk of deploying this feature. The CEO is breathing down your neck, I know, because I do that to my people, because every day this gets delayed, it's costing the company money. So what do? Normally, this means you need to contact DevOps and get them to build you a copy of the environment, and this takes a couple days. Then you need to install a bunch of complicated monitoring tools. This takes a few more days. Then you need to configure all those tools. And this, once again, takes a few more days. So it's already been weeks before you're finally ready to begin the job of validating the security of this new feature before you push it out to the rest of the world. With the combination of HyperQube and Rezilion, we can drop that weeks-long delay down to just seconds. So we're going to start inside of HyperQube. HyperQube is a no-code drag and drop solution for building and managing your environments. All right, so I've started with a blank environment, and I'm now going to build out an example of a production environment that I would have instrumented with Rezilion. So we're going to start off with a network. And then once I have a network, we're going to connect that network. We're going to supply internet access to that network. And then once I've got internet access, I'm going to deploy a couple virtual machines that are going to be hosting all of my containers. So let's deploy maybe 2 CentOS boxes and an Ubuntu box. We'll wire everything up. Oops, if I could click on the right picture. And then once we've got everything wired up, we can turn it all on. So behind the scenes, HyperQube built all the infrastructure for you. All you had to do was turn the picture. Now that I've got everything up and running, I can pop into my virtual machines to do any kind of additional configuration I might need to, download things, any sort of extra setup steps. So that's how easy it is to build environments. Once I've built my environment, I can take that whole thing and save it as a template with just 2 clicks. So click, click, and that'll kick off the process to save that environment as a template. But remember a couple minutes ago, I told you you're a security architect and you want a copy of the production environment containing this new feature. Well, to do that, it only takes 2 clicks. 2 clicks, 10 to 15 seconds later, and I now have a copy of the production environment that has the new feature inside of it, and I'm ready to get to work validating the security. And here's my copy of the production environment. With that, I'm going to turn it over to Greg from Rezilion, who'll tell you how you can monitor the containers on that environment.
Thanks, Craig. So this is our actual dashboard, but before I go into the actual demo of it, I want to talk briefly about the product itself. So Rezilion is a DevSecOps automation platform that allows you to go to the bottleneck by automating security within your environment. You have to think of DevSecOps in every environment. Now, your company may not have a very mature DevSecOps environment, but you're still doing the same things. Development wants to make sure that they're making as much code as possible. Security wants to make sure they don't get on the front page of the newspaper, or I guess today, to be honest, is being LinkedIn on every single post. And ops wants to make sure that their code going out there is going to keep running and not go down. So Rezilion allows platforms to work together effortlessly to know their total attack surface across production, development, cloud, and even applications, IoT devices. You can see everything you want to see in your environment to make sure that you know the total attack surface and what's going on. And this way, teams can work together seamlessly and easily, and I'll show you that through the demo, to make better things, to innovate faster and more secure than ever. Now, the product I can show you is called Rezilion Prioritize, as we talked about it, and it shows you everything that's loaded in memory, because you see every single bit of code that's running, and I'll show you that as well. And that way, you focus on what you want to do to make sure everything's being done properly, and you focus your patching efforts where they have to be. So this is actually a little sandbox we put together with HyperQube. And as you can see, it's a very small environment with like 2 workers and 6 container images. You can see here on the left. And let me just go a little higher, so the vulnerability count, with about 4,000 vulnerabilities in them. Now, I know this is a small environment, but in your own environment, as we scale bigger and bigger, the numbers kind of stay the same. We always see an actual amount of code not running around 70%, maybe higher, maybe a bit lower, but always in that situation. As you can see, we've also put in here ways for you to quickly and easily click to find which IP you're working with, packages, anything you want to find with the environment, quick and easy. Now, if I go down a little further, you can see all the containers we put in there. Now, I'm going to pick, of course, on the big baby. This is what everyone seems to use all the time. But first, I'm going to show you the overall attack surface of this environment. And you can see in this environment, in this case, almost 77% of the code never loaded. That means that that code isn't being loaded in memory and isn't easily exploitable in the wild. So you don't necessarily have to focus on that when you're actually doing patching. This gives you a lot more time to do patching as normal. Now, as you see here on the left, this is where we get every single scanner. In this case, we use Triby. If you're using something else, like let's say, I can't think of a name right now, but Qualys, one of the other scanners, it gives the exact same information. We don't make this information up at all. We are not a scanner. This just comes from the scanner itself. So you can see right now, there's 176 critical and 1,235 of them that are high. So if I go into the actual container, because we talk about container security, so I go down to one container itself. I apologize, I'm in Canada crossing, and I don't have an edge location running, so it's a bit slow at times. So once I go into one container, I'm going. So one container, right now you can see I have 7 critical and 55 high. Most of the time we're doing patching efforts, you know that security will tell dev to go patch the high and critical first, because that's what they worry about. But if I take the not loaded away, you'll quickly and easily see how that drops the number down dramatically. So automatically, we've gone to only 14 high and critical. So you can patch those quick and easy on the actual thing. And this is within one container. What's even more scary when you think about it is we pulled this container down about a month ago from Docker Hub. Nothing is Docker Hub. You can see there's actually 2 critical vulnerabilities in the wild in Docker Hub. So that has to be patched. We've done as well, and there's a lot of information in this dashboard, so I'll run through it all. You can see the top vulnerable packages. This is kind of like GPS in a way. This kind of tells you exactly where to go and where to focus. So as per normal, IPSI seems to be the #1 actual package that seems to have most of the vulnerabilities. So it'll tell you when you click on here exactly where to go, where to patch, make it quick, easy to where you got to patch and make your information go forward. Now here's where we list all the CVEs. We put a little pivot table in here for you. If you're like me, the older people who like making pivot tables, you can see where you go by score, package, host, all this type of things. So you can pivot out where you want to patch first. As well as, if you remember on the top, there's a drop-down list. You can look for certain CVEs in your environment. This is really good because if you read, especially if an executive, as Craig was saying, if your boss, a CEO, says, I was reading the paper this morning or on LinkedIn or something, I'm worried about the CVE, I'm worried about this one. You can quickly and easily look here and see, is that CVE in your environment? If it is, you can click on it, know exactly where to go, exactly where to patch it, exactly what you have to do right away. As well, we do here, this is the OS distribution. Sometimes when there are actually vulnerabilities, or we're talking containers today, quite often just upgrading the OS can make a big difference in your environment. The host can be actually one of the problems. So quickly and easily you can see if your host is the issue or not being the issue as well. And for people who like CLI, like I do, and like knowing more and more information about everything, we take all the information from the container itself, timestamp it so you can watch trending, CVE number, what the CVE actually means, the effective score of it, all the information you could ever want, all here in one place. So as you can see, we can quickly and easily see inside the container what vulnerabilities are there, what vulnerabilities have to be patched, where you have to go, where to focus your patching. So quickly and easily, you can make those containers more secure than ever. Now, you can do even more with this and get your DevOps, SecOps teams to work even better. Because as you know, you don't want to have your actual developers patching things that aren't necessarily being loaded. So for example, if they're using open source code, which we didn't show here, they might be using a little part of it, which quite often is a small part. And there could be, I'm making this up, of course, there could be a joystick driver, a USB driver, other drivers in there they never even touch. You don't have to patch those right away. They should at a later point, but the point is you want to get the maximum amount of your patching effort. The best way to do that is through our tool, because it'll show you where to focus your patching when you have to do it. So the next dashboard I'm going to show you is what we call the exits and loaded, which really is showing you all the code in your environment. The way we run, and you see a little error come up just because I'm crossing. This doesn't happen in normal environments, just so you know. So as you can see, all of them show up here, and we see every single file. Because the way we run our script, it runs and sees every single file that exists in your environment. So again, we do this. If I just go down to the one container again and pick on it, what I found amazing is we work with one of the biggest software companies in the world, and they have the same thing. About 90% of the code never loads, as you can see over here. And again, with this one, is 82% of the code is not being used actually at all. Now, could be code bloat, technical debt. It could be a lot of things. So what we can do is we go down a little further. You can see this is, of course, the packages and histogram. You can see the languages being used as well. But I just want to show you at the bottom here. This is all the code. This is actually your software bill of materials. And as you know, President Biden put that legislation through, sorry, maybe I'm saying it wrong. But he put that legislation through saying any software being sold to the government has got to have a software bill of materials. We have it built in our software. It's not an extra feature, it's built in naturally. But because you see every single file being loaded, you know if that code is not being used, if you remove that code, it can never be vulnerable again, because obviously if it's not there, it can't be executed. We also take the hash. Hashing is important in the sense that you know if something's changed in the code. If you sell code to someone else, you'll know if the change happened on your end or happened on their end. And even more importantly, you can do searches on hashes from the top for anything that might be virus. So for example, crypto is happening a lot now, especially at Docker Hub. So if you want to check if there's any crypto running within those containers, quickly and easy, you can look at the hash. Someone can change the name of the file, but they can never change the hash. The hash will always show you what's really truly being there. So by doing this, not only are you able to see what vulnerabilities are there and what you prioritize on patching, but now you can see what's in the code, whether it be code bloat or technical debt. You remove that code so it never becomes a problem for you again. And finally, we do something that's really cool, and we call it image certification or container certification. And let me explain how this is so important. And let's go back to the DevSecOps example. Development's making code, and if we go back to what doesn't matter containers, but we go into container, if they have the containers here, and in this case, you only have the latest, but let's say how the one from behind, the latest they're working on, and let's say they're doing it for streaming of media. So you have movie 1, movie 2, movie 3, for example, because there's a web server trying to know. So what happens now is the developer goes to the actual image or container and pulls it, and they know based on what security set they're rating at. So security will say maximum CVS score that I'm okay with is 6. And it's whatever you want. In this case, we set it for 9. You can set for whatever limit you want to make it for. Then they pull that container out. They know that it's hit the security check mark already. They can work with it. They then put it in, do the code work change they want to make, put the video in, do all the stuff. They put up again, they call it movie number 1. It gets scanned again by Rezilion, and then operations can pull it and see, it has passed. I can put it in development. I know it's passed the security check. So now everyone's working harmonized. They're working together as one, very quickly and automated. There's no delay in that part. However, let's say they get a situation like this where it says 1, it hasn't passed, then quickly they can go down here, see what the packages they have to patch are, and they can know exactly what they have to focus their patching so they can get it certified. So then it goes back from operations or security back to development, get the patching done quickly and easily. They can set it up, know exactly where to focus. It's clear security and go out there. And that way, DevSecOps can work as DevSecOps in a very automated process and go through everything quickly and easily. So we always say that you have this question all the time. You can stay safe and move slow. You can move fast and be exposed. But we at Rezilion say, why not move fast and stay safe at the same time? And by using Rezilion, DevSecOps can be automated from end to end and be as quick as each other and be as agile as they can be. So back to you, Craig.
Thanks, Greg. Let me just share my screen here. So key takeaways, paramount to success. Containers from public repositories should never be used before performing vulnerability scans. Not all vulnerabilities pose a risk. Only the ones that are in code running memory are exploitable. And it's very important to set security baselines and have a user-friendly way to meet them without slowing down development. For the latest information on HyperQube and Rezilion, follow us on LinkedIn and Twitter. Any questions about live infrastructure or vulnerability validation, please email sales@hypercube.io and info@rezilion.com respectively. And now we'll answer any questions that came in through the chat. Jessica?
Yeah, so our first question comes from Christian Bear. And so I think this is to you, Greg. Is it preferable to scan the container images, the containers themselves, or both?
Both. So you want to look at the whole. You want to look at the whole stack. I didn't mention that, but we look at the stack all the way from the OS up to the container itself. So you want to see actually what's running the container itself, and actually the host is running on. And now we can see everything and patch everything. Because of course, you can pull the container, put it anywhere you want, and run. Of course, that's what containers are for. But you want to make sure nothing's vulnerable at all, so that we can check the whole stack, not just one part of it.
Awesome.
Fantastic. All right, great. It looks like we have another question from Gabe Martinez. So this is going to go to Craig. How would I integrate HyperQube within my stack?
Sure. So HyperQube is great at fixing the bottleneck of having to go talk to DevOps or DevSecOps and get them to build me a copy of an environment that I can test and validate inside of. So depending on how complex the environment is, that can take a couple days, that could take weeks, that could take up to a month if it's a really massive environment. But with HyperQube and 2 button clicks, I can get a copy of the environment and do whatever I need to inside of it. So we agree with Rezilion. You should be able to both go fast and stay secure.
Thank you, Craig.
All right. Do we have any other questions? All right. So we have another one from Gabe. As a follow-on, how would I test the integration of multiple products using HyperQube?
Sure. So HyperQube gives you a blank canvas that you can install whatever you want inside of. So you can take Rezilion's product, any of your other products, and integrate them all together inside of one giant environment and make copies of it with the click of a button. So suppose you're trying to evaluate how a new product might integrate into your existing infrastructure. Once again, the way you used to do that is you go contact sysadmin or DevOps and you say, hey, I need a copy of our infrastructure so I can test out this new product, because you don't want to take down production. And then you wait a week or 2 weeks or whenever they get around to it. So with HyperQube, it's 2 clicks. I have a copy of my infrastructure and I can get to work immediately testing the integration of some new product.
Awesome. Thanks, Craig. Next question is for Greg from Allison. How do you measure the ROI of vulnerability validation?
Well, you have to remember when you're doing actually vulnerability validation, you can look at the time it takes. So we assume it takes about 3 hours per or so to do an actual patch on it. But a lot of people don't think about everything involved with patching. So you have to remember, when there's a patch to be done, you have to find the patch, you have to test the patch, make sure the patch and break code. There's so much to be done. So we say it takes about 3 to 6 hours per patch. So you can imagine quickly, if even in this situation, if we took away what was like 600 vulnerabilities on the small environment here, multiplied by 3 hours, the ROI is dramatic. Because when you're doing patching, a lot of people don't think about the overall involvement with it all. Because finding the patch, make sure the patch works, is so much involvement that, so it takes 3 to 6 hours on the actual ROI. So we actually at Rezilion, we have an amazing calculator we can use for you. So we can actually take your data during a POV, which doesn't take much time, about 15 minutes setup, about 24 hours to run it. And we can actually take your actual data and show you your true ROI and roughly what it will be for you to use our product versus using it without. So, but basically we do it, you can take all the patches, take away. So assume whatever your number is based on what scanner you're using today, take away 60% at a minimum, multiply it by 3 hours, and that's roughly your ROI.
All right, fantastic. Well, I don't see any more questions. So thank you to the hosts and the attendees, and thanks to Rezilion and HyperQube. And again, you can find more information about HyperQube and Rezilion on our LinkedIn pages or our websites. But we hope to see you for our next episode. And again, thanks for attending.